Hi everyone, in the last video we have seen that instantaneous velocity at a time t1 is the limit of this expression when t2 tends to t1. In other words, when the difference between t1 and t2 is approaching 0, this expression reduces to the velocity at a time t1. I'll talk about the limit in this video. Suppose you want to find the area of this circle. We know this area is pi r square. But let's fit a triangle of equal sides in this circle. Area of the triangle is 3 times the area of this tiny triangle. This angle is 2 pi by 3. So this angle will be pi by 6 because the sum of the interior angle of this tiny triangle must be pi. Area of this tiny triangle is half of the base multiplied by height. Total area of the triangle will be the 3 times the area of this tiny triangle, that is 1.299 r square. We can find the area of the square in the same way. Area of the square will be 4 times the area of this tiny triangle, that is 2r square. Similarly, we can find the area of the pentagon, hexagon, heptagon and so on. As we are increasing the number of sides, area of the polygon is increasing, because it is covering more spaces left inside the circle. Pause and ponder. What will be the area of polygon as we increase the number of sides? I have plotted the area of polygon on the y-axis and number of sides on the x-axis. As you are increasing the number of sides, the area of polygon is approaching the area of the circle. When the number of sides is very high, say infinity, then area of polygon will become equal to an area of circle. Now this is interesting. We will find the area of the polygon in terms of the number of sides first. Let's make a polygon of side n. Area of this polygon will be n times the area of this tiny triangle. This angle will be 2 pi by n. Suppose this angle is theta. So the sum of the interior angle of this triangle must be pi, so we have this. Area of polygon reduces to this. When n equals 3, this will give the area of the triangle, and when n equals 4, it will give the area of the square and so on. See, when n tends to infinity, this expression reduces to the area of the circle. As we increase the n, this polygon converges to a circle. In the same way, we can find the circumference of a circle. This length will be 2r cos theta. So the perimeter of the polygon will become n times this length. For a different values of n, we can get the perimeter of polygon from this expression. Put n equals 3, you will get the perimeter of triangle. Put n equals 4, you will get the perimeter of square. As we increase the number of sides, see how the perimeter is increasing. Let's find out the perimeter when n is very high, say infinity. In other words, the limit of this expression when n tends to infinity. This expression reduces to 2 pi r. Amazing! This is the circumference of a circle. So in this video, we got to know that area of polygon when the number of sides is approaching infinity is equal to the area of circle. And the perimeter of polygon becomes equal to the circumference of a circle. In another way, at infinity, the polygon becomes a circle. Thanks for watching.